Okay, so welcome to my channel on managerial economics. And in this particular video, I'll be doing part 3 of the series on game theory. So please, if you have not subscribed to the channel, please do so, like, comment, and share. Okay, but most importantly, subscribe to the channel. Let us have your feedback, and then we can bring you more content. So in this particular video, I'll be teaching on application of one-shot simultaneous games to output decisions. Okay. Now, for us to understand this particular video very well, please do well to watch my videos on oligopoly, which will give you an in-depth knowledge about how to find the output and then the profit for the different models of oligopoly. All right, because we will be applying them here. And as well, to understand this video, kindly also watch part 1 and part 2 of my series on game theory. Now, in this particular video, I'll be teaching on application of one-shot simultaneous games to output decisions. Now, when it comes to output decisions, firm makes output decisions, especially in an oligopoly. Firms make output decisions by using either the Cournot or the Stackelberg, or even the Cournot or the Stackelberg model. That is when the firms are not agreeing to coordinate. But when they agree to coordinate, they can make output decisions based on collusions. All right. So I taught this in the video on oligopoly. So please watch that video. You'll get more knowledge into what I'm saying. Now here, we are going to apply game theory to output decisions. Now, this example says that suppose the market demand for two firms is given as Q1 plus Q2 is equal to 53 minus P. The cost incurred by the first firm by producing the last unit of output is 10 cedis. That means that the marginal cost of firm 1 is 10 cedis, whilst that of the second firm is 12 cedis. So the marginal cost of firm 2 is 12 cedis. Suppose firm 1 is the leader and firm 2 is the follower, as in a Stackelberg oligopoly. A, what is the profit for each firm and the total industry profit if the fixed cost of the first firm is 40 cedis and that of the second firm is 20 cedis? All right. This question has been solved already in my video on oligopoly. So I'm just going to share with you the output for the two firms and then the profit for the two firms. Okay, so if you solve this using the Stackelberg model, which the question is saying, you realize that the output for firm 1, which is the leader, you get the output for the firm 1 to be 22.5 units, okay? Then you get output for firm 2 to be 9.25 units. And if you solve for their profit, you get profit for firm 1 to be 213.125 cedis, and then profit for firm 2 to be 65.5625 cedis. Okay, so please do watch my videos on oligopoly, solving the output and then the profit. You'll get more knowledge there. Here I try to summarize it because it will make the calculations more cumbersome. So once you already know this from that video, you should be able to work it up to this point. So here, that is when both firms are choosing output based on Stackelberg. So Stackelberg for both firms. Okay, so that was the requirement of the A. A says, what is the profit for each firm and the total industry profit if the fixed cost for firm 1 is 40 and that of firm 2 is 20? So once you add the profit for each of the firms, you get a total industry profit. Now, let's look at B. B says that now suppose that there is neither leader nor follower, but each firm acts to maximize its profit, taking its rival's output as given. What are the profits for each firm? So in the B here, the question is saying that now suppose there is no leader, there is no follower, but each firm maximizes profit by taking its rival output as given. This is a clear example of Cournot, because in the Cournot model, I taught in that video that if a firm chooses his profit or if a firm chooses his profit maximizing output, taking the other firm's output as given, we are talking about the Cournot model, all right? So based on the figures or based on the metrics in the example, if you solve the Cournot model from the knowledge from oligopoly, I taught that in my video on oligopoly. So when you solve it, you get the, so when we have Cournot for both firms, okay? When we have Cournot for both firms, the output for firm one, based on, I mean, their marginal cost, their fixed cost and everything, the output for firm one will be 15 units. And then the output for firm two will be 13 units. All right. So based on the fixed cost given in the question, once you solve their profit, the profit for firm one will be, so if you solve it, the profit for firm one will be 185 because the output is 15. The marginal cost. So remember, in getting profit, is output into bracket, price minus marginal cost, bracket close, minus fixed cost. We did that in the oligopoly. So it will be 15 into bracket. The price for firm one is 25, or the industry price, because the question says price is equal to 53 minus Q1 plus Q2, okay? So this will give us 53 minus 15 plus 13. And the industry price will be 25. So profit for firm one, remember, is Q1 into bracket price minus marginal cost one minus the fixed cost. So here we will have the units, that's 15 units into bracket price 25. The marginal cost for firm one was 10. Then the fixed cost in the question is 40. So once you solve it, profit for firm one will be 185, okay? Then profit for firm two will be the units, 13 into bracket price 25 minus marginal cost 12 minus the fixed cost 20. So we will get 149, okay? That'll be 149. Okay. Now let's go back to the question and let's look at its requirement again. Now C says that assume that if these two firms collude, each of them can reduce its fixed cost to 15 and marginal cost to 4. Remember, when I was teaching you collusion, I think that was the last video on my series on oligopoly. I said that once they collude, okay, each of them will have common fixed cost and they will have common marginal cost. Because once they collude, they are sharing industry output equally. What it means is that none of them will have a different fixed cost. So the one cannot have 15 cedis fixed cost and the other one will have 30 fixed cost. No, all of them will have similar fixed cost. So here, in this question, it means that each of the two firms will have 15 cedis fixed cost and each of the two firms will have 4 cedis marginal cost. Remember, when I was teaching you collusion, once they collude, they become like a monopoly, okay? So there is no need dividing the fixed cost into 2 and dividing the marginal cost into 2 and adding them back. We can just pick one of them to represent the entire industry. For further insight to what I'm saying, just watch my video on collusion, you get better insight. So here, if they collude, the price function will now become 53 minus Q because Q1 will now add to Q2, then we have the industry output. Then the total cost function will be the fixed cost, which is 15, plus the marginal cost, which is 4. So marginal cost is 4. So once we want to look at the total cost, when you differentiate total cost, you get marginal cost of 4. So it means that when you integrate, so here we have the marginal cost to be equal to 4. Once we integrate the marginal cost, we will get fixed cost plus 4Q. All right. And since the fixed cost is given as 15, So it means that the fixed cost is 15. So total cost equals integral marginal cost. Okay. So the fixed cost is 15. Then we have, so this is the total cost function. All right. Now, once they collude, they now become like a monopoly. So for monopoly, the profit maximizing output is when marginal revenue is equal to marginal cost. So price is equal to 53 minus Q. Total revenue is price times quantity. So we will have 53 Q minus Q squared. So marginal revenue, which is change in total revenue over change in quantity, we will have 53 minus 2Q. All right. Then remember, the marginal cost is 4. So at equilibrium, marginal revenue is equal to marginal cost. And that will be 53 minus 2Q is equal to 4. All right. So here we have 53 minus 4 is equal to 2Q. So that will give us 49 is equal to 2Q. All right. So Q is equal to 24.5. So if the industry output is 24.5 and the two of them are sharing industry output, it means that you divide this by 2. So the output for firm 1 will be 12.25. The output for firm 2 will be 12.25. Now, if you want to look at the industry profit, okay, you find the total revenue for the industry. Now, remember that total revenue is price times quantity, okay? So here, the price is equal to 53 minus Q. So that will be 53 minus 24.5. So the price will be 28.5. So total revenue will be price times quantity. That will be 28.5 times the industry quantity, 24.5. So that will give us 698.25. Then the total cost is, remember, it is 15 plus 4Q. So we have 15 plus 4 into brackets. The industry quantity is 24.5. So this will give us 585.25. Okay. Then the profit will be total revenue minus total cost. So that will be 698.25 minus, sorry. I think the total cost, when you punch the calculator, the total cost will be 113. Sorry. So we now have 698.25 minus 113. Okay, 113. So this will now give us 585.25. Okay. Alternatively, we could have used our shortcut formula, which says that profit is equal to quantity into bracket price minus marginal cost minus the fixed cost. So here, the quantity for the industry was 24.5. The price is 28.5 minus the marginal cost 4 minus the fixed cost of 15. You get the same answer as 585.25. Okay. So to get the profit for each firm, we will now divide the industry profit between the two. So when you divide it, the profit for firm 1 will be 296.625. Profit for firm 2 will be 292.625. Okay. Now, the next one says that the managers of these firms realize that explicit agreements to collude are illegal. Each firm must decide on its own whether to produce the Stackelberg quantity or the cartel. Cartel simply means collusion, all right? So to produce the Stackelberg quantity or the cartel quantity, compute the profit from the profit of each firm from the likely combinations. Now here, not to confuse yourselves, we must summarize the output, we must summarize the marginal cost and the key variables. Otherwise, you confuse yourself. So let's look at Stackelberg. Let's look at Cournot, and let's look at Collusion. All right. So I'm going to summarize the key variables so that we don't get ourselves confused. So quantity one, or quantity for firm one in the Stackelberg scenario was 22.5. For firm two, the quantity was 9.25. Remember that the marginal cost for firm one, so that I'm naming it MC1, is 10. It's 10 under both Cournot and Stackelberg. The marginal cost for firm two is 12 under both Cournot and Stackelberg. The fixed cost for firm one is 40 under both Cournot and Stackelberg. The fixed cost for firm two is 20 for both Cournot and Stackelberg. Remember that. It was in the question. Also remember that the Cournot output for firm one, the Cournot output for firm one was 15. Then the Cournot output for firm two was 13. Okay. All right. Now let's come to Collusion. Remember that the Collusion, the output for firm one was 12.25. The output for firm two was also 12.25. The marginal cost for firm one, remember the question said that if they collude, the two of them will reduce their marginal cost to 4 each. All right, so 4 is the marginal cost for firm one. When they collude, 4 is also the marginal cost for firm two when they collude. And the question also says that if they collude, both of them will reduce their fixed cost to 15 each. All right, so the fixed cost for firm one will be 15, the fixed cost for firm two will be 15. So this particular summary table is essential so that you don't confuse yourself, all right, in the calculations. Once you don't do this table, you may likely confuse yourself in the calculations. So the question says that each of them is free to either go Stackelberg or Collusion. Each of them is free to go Stackelberg or Collusion. Determine the likely outcome. Now let's assume firm one goes Stackelberg and firm two goes Collusion, all right? Collusion. Now remember that if firm one goes Stackelberg, his output is 22.5 from the summary table. And if firm two goes Collusion, firm two's output will be 12.25. Remember that. That is why this summary table is very important. Okay, so the price, which is 53 minus Q1 plus Q2, the price will now be 53 minus 22.5 plus 12.25. So the price will now be 18.25, okay? So the profit for firm one, remember the profit, the formula is Q into brackets, the price minus marginal cost, bracket close, minus the fixed cost, okay? So the quantity for firm one is 22.5. The price is 18.25. Remember, the marginal cost for firm one when he is choosing Stackelberg is 10, okay? Minus the fixed cost, it was 40. So once you do this, you get 145.625. Okay. The profit for firm two. The quantity for firm two is 12.25. The price is 18.25. Now, if firm two plays Collusion, all right, if firm two plays Collusion, his fixed cost will now be 4. Okay, so price minus the marginal cost. So he reduced his marginal cost to 4. So price minus the marginal cost is this. minus, he will reduce his fixed cost to 15. So the final answer will be 159.5625. Okay. Now let's also assume, because all these are what if analysis. Remember that all that we are doing is what if analysis. Okay. Now let's assume that firm 1 rather plays Collusion and firm 2 plays Stackelberg. Now, if firm 1 plays Collusion and then firm 2 plays Stackelberg, remember that firm 1 is how his output will be 12.25. Remember that. And then if firm 2 is now playing Stackelberg, his output will be 9.25. Okay. So we are just doing what if analysis here. So the price will be equal to 53 minus 12.25 plus 9.25. So we have the price to be equal to 31.5. Okay. So the profit for the first firm will be the output 12.25 into bracket the price 31.5 minus the marginal cost of 4, because when he's playing Collusion, his marginal cost will be 4. Okay, minus 15, because when he's playing Collusion, his fixed cost will be 15. So this will give us 321.875. Then firm 2, that is playing firm 2, that is playing Stackelberg, his output is 9.25, the price is 31.5. Then if he's playing Stackelberg, firm 2 is playing Stackelberg, his marginal cost is 12, and then his fixed cost is 20. So we will now have 160.375 as the final answer. So we can now represent this in a normal form game. So we are looking at Stackelberg, okay, Collusion. So here is firm 1, all right, and let's say up here is firm 2. We are looking at Stackelberg, and we are looking at Collusion as well. Okay. So now let's go back to our answers. Remember that when it's Stackelberg for both firms, firm 1 gets a profit of this, firm 2 gets a profit of this. Okay. Now, when it is Collusion for both firms, remember that each of them will get a profit of this and this. Okay. So let's go and write them. So Stackelberg. The profit for firm 1 is 213.125. Then the profit for firm 2 is 65.563. Okay. When they both collude, the profit for each of them is 292.63. If you round to 2 decimal places, 292.63. Then, if firm 1 plays Stackelberg, but firm 2 plays Collusion, remember, firm 1 plays Stackelberg, firm 2 plays Collusion. Firm 1 will get this, and firm 2 will get this, okay? So we are going to represent them here. So we have 145.625 for firm 1, then 159.5625 for firm 2. Now, instead, if firm 1 plays Collusion and firm 2 plays Stackelberg, okay, firm 1 will get 321.875, firm 2 will get 160.375. So we will have 321.875, then firm 2 will have 160.375. Okay, now let's do some analysis. So here, in this particular analysis, we realize that if you want to check the dominant strategy for firm 1, we will hold firm 2 at Stackelberg. So when we hold firm 2 at Stackelberg, firm 1 is better off playing Collusion because 321.875 is better than 213, all right? If you also hold firm 2 at Collusion, firm 1 is still better off playing Collusion because 292.63 is better than 145. So the dominant strategy for firm 1, okay, is to play Collusion. On the other hand, if we hold firm 1 at Stackelberg, firm 2 is better off playing Collusion because 159.5625 is better than 65.563. If you also hold firm 1 at Collusion, firm 2 is still better off playing Collusion because 292.63 is better than 160.375. So the dominant strategy for firm 2 is also to play Collusion. Now here, none of them have a pure secure strategy because both of them have a dominant strategy, all right? And then the Nash equilibrium will occur at where both of them play dominant. So the Nash equilibrium will be to play Collusion, all right? And then the payoff at the Nash equilibrium will be 292.63, 292.63. Okay, so that will be the analysis. Let's take a second example. So given this page, so in the question, the question says that what is the Nash? We have done it. The secure, the dominant, the normal form, we've done it. Now, given this payoff matrix, what output strategy is each firm likely to pursue? So each firm is likely to play a Collusion output strategy, all right? So that will be the answer to this. Let's look at this example. Two firms produce auto seat covers. Now, each firm has a cost function of this, 20 kilo plus kilo squared. Taking the market demand for seat covers is represented by P is equal to 200 minus 2 Q, where Q is equal to Q1 plus Q2. If each firm acts to maximize its profit, taking its rival output as given, as in Cournot, what is the equilibrium quantity and what is the profit for each firm, all right? So please, based on our knowledge of Cournot, we know what to do to get the quantities, all right? So in this second example, I'm not going to solve the quantities, but based on our knowledge in Cournot, we can find the quantities. You can watch the video on the Cournot, you get much more detailed knowledge on that. But based on our knowledge in Cournot, if you solve it thoroughly, you will get, all right, so when you solve to get a Cournot output, you get 22.5 for each, all right, 22.5 for each. Okay, but then we will come and solve all their profit, but it looks like something has been left out in the former question. So please forgive me for that. Let's go back to the former question, before we come back to question 2. Okay, I left something out. Okay, now in the former question, it says that suppose instead that the managers of these firms realize that explicit agreement to collude are illegal. Each firm must decide on its own whether to produce Cournot or the collusion or the cartel, all right? Compute the profit from the likely combination. So sorry about that I skipped to question 2. Let's resolve this one for question 1 before we go to question 2, okay? All right, now remember this particular table. Let never forget the summary table. This one here. Let never forget this summary table. All right. Never forget this summary table. Okay. So if M1 plays Cournot and M2 plays Collusion, all right. So here we are assuming that M1 is playing Cournot and then M2 is playing Collusion. Remember that if M1 plays Cournot, his output is 15. So we have 53 minus KO1, which is 15. And if M2 plays Collusion, his output is 12.25. Okay. So we have P is equal to 225.75. All right. Now the profit for M1 will be equal to the quantity, which is 15 into bracket the price, 25.75. Minus the marginal cost. Remember that if M1 is playing Cournot, remember that his marginal cost will be 10. All right, his marginal cost will be 10. Then his fixed cost will be 40. So once we solve this, we will get 196.25. Then M2, once he plays Collusion, his output is 12.25. Okay, his price is 25.75. And then remember, once he plays Collusion, his marginal cost will now become 4. Okay, minus the fixed cost is 15. So once we do this, the profit will be 251.4375. Then, if M1 rather plays Collusion and M2 plays Cournot, the price, of course, will be 53 minus, if M1 plays Collusion, his output is 12.25. Then, if M2 plays Cournot, his output is 13. So you have price to be equal to 27.75. Then we will have profit for the first firm is equal to the output, which is 12.25 into bracket the price, 27.75 minus the marginal cost 4 minus 15. So this will give us 275.9375. Then for firm 2, the output is 13, the price is 27.75. Because firm 2 is playing Cournot, remember if he plays Cournot, his marginal cost is 12 and then his fixed cost is 20. So after solving, you get 184.75. Okay. So let's summarize this. Remember that so here we have firm 2, firm 1. So we have Cournot, we have Collusion, and we have Collusion here as well. Okay. So remember, so here is firm 1 and here is firm 2. Remember that from our Cournot calculation for this particular question 1, when they are both playing Cournot, firm 1 will get 185 profit, firm 2 get 149. And when they both collude, remember that each of them will get 292.625. 292.625. Okay. But when firm 1 plays Cournot and firm 2 plays Collusion, firm 1 will get this, firm 2 will get this. All right. So we will have 196.25, 251.4375. Then when firm 1 plays Collusion and firm 2 plays Cournot, this and this will happen. So we will have 275.9375 for firm 1, comma, firm 2 will be 184.75. Now let's do the analysis. If we hold firm 2 at Cournot, Firm 1 is better off playing Collusion because 275.9375 is better than 185. If we hold Firm 2 at Collusion, Firm 1 is still better off playing Collusion because 292.625 is better than 196.25. So the dominant strategy for Firm 1 is to play Collusion. Then if you do for Firm 2, you realize that the dominant strategy for Firm 2 is also to play Collusion, all right? So in this question, there is no pure secure strategy for either of them. And then the Nash equilibrium will occur at where collusion meets. So the Nash equilibrium is collusion, all right? And then the payoff at the Nash equilibrium will be 292.625, 292.625. Okay, so that will be that. So let's add the second example now, and then we'll be done with application to output decisions. Okay. Now, in this question, there's one cost function, there's one price function, okay? Now, this portion says that if each firm plays Cournot, what will be the output and what will be the profit? So if you're able to go through the calculations and find the output and then the profit if each firm plays Cournot. It occurs to the managers that they could do a lot better by colluding. If the two firms collude, what will be the profit? So we will solve this thing in terms of collusion. So in terms of collusion, this will be the inverse demand, this will be the cost function, and you solve them like a monopoly and get the profit and share for them, all right? So that's one, two. You have been taught in the former videos how to do that. So please go through and then solve them. Now, if the managers of these firms realize that explicit agreement to collude are illegal, each firm must decide on whether to produce Stackelberg or cartel. Okay, compute the profit from the likely combinations. Now here also, because of what you've learned in the first example, you should be able to do this as well. Then suppose instead that the managers of these firms realize that explicit agreement to collude are illegal, each firm must decide whether to produce Cournot or cartel, compute the profit. So that means that you put the Cournot and cartel in the price function and find the profit for each of the firms in the likely combinations. Of course, here also you've learned it from the former video and you should be able to get these outcomes, okay? Now, if you solve them correctly, when both firms produce Stackelberg, okay, firm 1, which is the leader, so profit 1, so profit for firm 1, which is the leader, will be 1542.86. Then the profit for the follower will be 1377.74. Okay. Now, if they play collusion Stackelberg, okay, the firm that plays collusion, that's firm 1, will get a profit of 1382.1. And then the one that plays Stackelberg, that's firm 2, will get 1836.77. Okay. Now, if they rather play Stackelberg collusion, okay, firm 1 that plays the Stackelberg, so if they rather play Stackelberg collusion, the firm 1 that plays Stackelberg will get a profit of 1873.49, and firm 2 that plays the collusion will get 1253.7. So please go over these calculations to get these answers. And if both of them collude, right? If both of them collude, firm 1 will get a profit of 1575. Firm 2 will get a profit of 1575. So we can draw this in a normal form. So once we draw it, we will have Stackelberg collusion. We will have Stackelberg, Collusion here. Okay. Then this will be the outcomes. So Stackelberg, the profit will be 1542. So here is firm 1, here is firm 2, right? Firm 2. Okay. So the outcome will be 1542.86 for firm 1, then 1377.74 for firm 2. If they both play collusion, we will have 1575, 1575. If firm 1 plays Stackelberg and firm 2 plays collusion, we will have 1873.49 for the firm that plays Stackelberg. Then we will have 1253.7 for the firm that plays collusion. Okay. Then if firm 1 plays collusion, he will get 1382.1. Then firm 2 who plays Stackelberg will get 1836.77. So if you work it out, you realize that the dominant strategy for firm 1 is to play Stackelberg. And then firm 2 too, his dominant strategy is to play Stackelberg. Okay. Is to play Stackelberg. That means that the Nash will occur at Stackelberg. Okay. Then the outcome of that will be 1542.86, 1377.74. Okay. Now let's look at a Cournot situation. If both of them play Cournot, each of them will get a profit. If you work it out perfectly, each of them will get a profit of 1518.75, 1518.75. But if the first place Cournot, then the second place collusion, the first or the firm 1 will get a profit of 1856.25. Then firm 2 will get a profit of 1350. Instead, if firm 1 plays collusion and firm 2 plays Cournot, firm 1 will get a profit of firm 1 will get a profit of 1350. So you get a profit of 1350. Then firm 2 will get a profit of 1856.25. So let's represent this one as well. Yeah. So we have Cournot, we have Cournot, collusion. And so when they both play Cournot, their profit is 1518.75, 1518.75. When firm 1 plays Cournot and firm 2 plays collusion, the profit will be 1856.25 for firm 1. Then the profit for firm 2 will be 1350. All right. Then if firm 1 plays collusion and firm 2 plays Cournot, the profit for firm 1 will be 1350. Then that for firm 2 will be 1856.25. Then when both play collusion, we will have 1575, 1575. So if you work this out perfectly, you realize that the dominant strategy for both firm 1 and firm 2 is Cournot. That means that their Nash equilibrium will occur at Cournot, and then the outcome of their Nash equilibrium will be 1518.75, 1518.75. Okay, so this will bring us to the end of the series of application of one-shot game to output decisions. So this is part 3 of my series on game theory. So Kindly subscribe, share, comment, and let us have your feedback. Much more importantly, subscribe to this channel so that we can bring you more content. So in the next 2 videos, I'll be teaching on coordination decisions, and I'll be teaching also on sequential games, all right? Sequential games. So please, we'll meet in the next 2 videos, all right? Thank you.